Hi, ma'am. This is T. Kushi from ITA, and my roll number is 37. And my topic for Tech Talk is observations of greenhouse gases as climate indicators. Coming to introduction, greenhouse gases are gases present in Earth's atmosphere that trap heat and keep the planet warm. Without them, Earth would be too cold to sustain life as we know it. However, since the Industrial Revolution, human activities like burning fossil fuels, deforestation, and industrial processes have significantly increased greenhouse gas levels, contributing to global warming and climate change. Why greenhouse gases are considered as climate indicators and how? So, greenhouse gases, especially carbon dioxide, methane, and nitrous oxide, are closely linked to temperature changes. Monitoring the concentration of these gases provides valuable data on health of our planet's climate system. This presentation will explore how these gases act as indicators of climate change, how they are measured, and what trends in their concentrations reveal about the state of our climate. What are climate indicators? Climate indicators are measurable variables or parameters that provide information about the state of the climate system and its changes over time. These indicators help scientists and policymakers track climate change by offering data on health and stability of Earth's climate. Greenhouse gases are one of the primary indicators of climate change. The concentrations of gases like CO2, CH4, and N2O, that is carbon dioxide, methane, and nitrous oxide, in the atmosphere give insight into the human impact on the climate and the warming effect they create. Other climate indicators include global temperature. Rising average global temperatures include warming, sea level rise. Melting ice and thermal expansion of oceans contribute to rising sea levels. Ice and snow cover. Diminishing glaciers and Arctic sea ice are clear signals of warming. Ocean acidification. As ocean absorbs CO2, their pH level decreases, impacting marine life. By monitoring these indicators, scientists can access trends, predict future changes, and develop strategies to mitigate and adapt to these climate changes. Key greenhouse gases. The key greenhouse gases contributing to climate change include carbon dioxide, methane, nitrous oxide, and fluorinated gases. CO2 is the most prevalent, primarily produced by burning fossil fuels and deforestation, and remains in the atmosphere for centuries, making it a major driver of global warming. Methane, though present in smaller quantities, is far more effective at trapping heat but has shorter atmospheric lifespan. It mainly comes from agriculture, landfills, and fossil fuel production. Coming to nitrous oxide, it is a potent greenhouse gas largely released from agricultural practices and industrial processes. With a long atmospheric lifetime, fluorinated gases used in refrigeration and manufacturing have extremely high global warming potential despite being emitted in smaller quantities. Together, these gases significantly impact the Earth's climate system. So, the greenhouse effect. Some solar radiation is reflected by Earth and the atmosphere. Some radiation is absorbed by Earth's surface and warms it. Uh, but some of the infrared radiation passes through the atmosphere, some is absorbed by greenhouse gases and re emitted in all directions by the atmosphere. The effect of this is to warm Earth's surface and the lower atmosphere. Global GHG concentrations over time. Since the Industrial Revolution, human activities have caused a significant rise in greenhouse gases. Carbon dioxide has increased from pre industrial levels of about 280 ppm to over 420 ppm today. Historical data from ice cores show that current CO2 levels are the highest in at least 8,008 lakh years. Methane and nitrous oxide levels have also surged due to agriculture and industry. The Keeling curve, which tracks CO2 since 1958, illustrates this steady rise, linking it directly to global warming and climate change. So, global greenhouse gas emissions are There is carbon dioxide with 11% of emission, methane 16%, nitrous oxide 6%, fluorine gases 2%, and carbon dioxide from fossil fuels and industrial processes is 65%. So you can know how much amount of carbon dioxide is being released in our day-to-day life and how is it related to climate indicators and global warming. Uh, Greenhouse gases emission by sector. So energy sector, that is 73%, the largest source primarily for burning fossil fuels for electricity, heating, and transportation. Coming to transportation, it is 16%. Emissions from vehicles, ships, and airplanes due to gasoline and diesel combustion. Industry is 21%. Emissions from manufacturing, chemical production, and energy use in industrial processes. Agriculture and forestry and land use is about 18%, includes methane from livestock, nitrous oxide from fertilizers, and emissions from deforestation. Buildings, it is 6%, emission from residential and commercial energy use for heating and electricity, and waste, that is 3%, methane emissions from landfills and wastewater treatment. So, global greenhouse gas emissions by economic sectors. So, electric and heat production is 25%, agriculture and forestry 24%, building 6%, transportation is 14%, industry 21%, and other resources it is 10%. So, majorly, if you have to come into detail, 23% will be industries, 38% will be transportation, 8% will be residential, 6% will be commercial, 9% for agriculture and forestry, 5% for electrical imports, and 11% for electricity in state. So, impact of these greenhouse gases on climate. First is global warming. GHG traps heat, leading to an increase in average global temperatures by about 1.1 degrees since the late 19th century. Extreme weather events. Increased temperatures results in frequent and intense events like hurricanes, heat waves, and heavy rainfalls. Melting ice and rising sea levels. Warming causes glaciers to melt, contributing to rising sea levels and threatening the coastal communities. Next is ocean acidification. Excess CO2 absorption leads to lower ocean pH, harming marine life and such as jellyfish and coral reefs. Feedback loops. Challenges like Arctic ice melt create feedback mechanisms that further accelerate warming. So, because of this climate change, you may have tornadoes, you may have volcanic eruptions, landslides, uh, ice melting, tsunamis, droughts, and forest fires as well. Monitoring and observing GHGs. So, it is very important to monitor these. Uh, some of them are satellite observations like NASA OCO to measure GHGs globally, providing comprehensive and high resolution data. Ground based monitoring systems, networks operated by organizations like NOAA, measuring GHG levels at various locations, including remote areas like Mauna Loa. Air sampling, air samples are collected and analyzed in labs for accurate GHG measurement, validating satellite data. Modeling and remote sensing, computer models predict future concentrations and access policy impacts, while remote sensing tracks changes in land use and emissions. So, adaptation, mitigation, and monitoring. These are the three steps that you have to take care for greenhouse gases mitigation. So, adapt to the negative effects of climate change, such as freshwater scarcity, food shortage, ecosystem or marine losses, weather risks to energy infrastructure. Mitigate sources of greenhouse gases. High carbon energy sources, unstable land use, and degrade natural carbon sinks. Monitoring sources of greenhouse gas emissions, ocean acidification, and threats to ecosystems. So, prediction and future trends. Emission increase. Without significant intervention, global GHG emissions could rise, potentially leading to temperatures increase of 1.5 to 2 degrees by 2050. Mitigation needs. To limit warming, 1.5 degrees Celsius emissions must be reduced by 45% by 2030 and reach net zero by 2050, requiring to shift to renewable energy and energy efficiency. Coming to source shifts, developing nations are expected to see rising emissions as they industrialize, while developed countries must lead in reductions. technology innovations, advances in carbon capture, renewable energy, and electrical vehicles are essential for reducing future emissions. Climate feedbacks. Warming could trigger feedback mechanisms such as Prefrost releasing more carbon and complicating mitigation efforts. Policy impact. Continued international cooperation, as emphasized in the Paris Agreement, is crucial for achieving climate goals. Climate action and mitigation. International agreements, renewable energy transition, shift from fossil fuels to renewable energy sources, energy efficient improvements, enhance efficiency in buildings, transportations, industries to reduce emissions. Carbon pricing, implement carbon taxes or cap and trade systems to incentivize emission reductions. Reforestation and afforestation, increase forest cover to absorb CO2 from the atmosphere. Sustainable agriculture, adopt practices that reduce emissions while promoting soil health. Community engagement, raise awareness and involve communities in climate action initiatives. So, mitigation and adoption. So, use renewable energy, more efficient industrial processes, eco friendly transportation, seasonal eating and less meat, increase in urban green areas, awareness raising, water and energy saving, more resilient agriculture species, entomological surveillance, flood barriers in urban spaces. So climate change, mitigation is nothing but reducing GHMC emissions, long-term focus on avoiding future impacts, global scale cross-sectional effort needed for effectiveness, and local or national nesting and collaboration needed. And for adaptation, reducing vulnerability, start with focus on current variability and sub or national global level collaborations needed. So coming to conclusion, in conclusion, addressing climate change through effective monitoring, mitigation, and international corporations is essential for a sustainable future. For those who need to take urgency of action, climate change poses significant risks to ecosystem, human health, and economics, necessitating to immediate and decisive action to reduce greenhouse gas emissions. Multi-sector collaboration, achieving meaningful progress requires collaboration across all sectors, including energy, transportation, industry, agriculture, and communities. Innovative solutions, embracing technological advancements, renewable energy sources, and sustainable practices can drive significant reductions in GHG emissions and foster economic growth. Global commitment, international agreements like Paris Agreement plays a crucial role in uniting countries around shared climate goals and fostering accountability, empowering communities. Engaging and educating communities is vital for driving grassroots action and fostering a cultural sustainability. So, climate solutions protect forests, manage timberlands, manage grazing lands, manage croplands, restore waterlands, restore forests, protect wetlands, protect grasslands as well. Thank you so much.